I worked for a little while at the NIH and then moved over to the FDA and worked in the Center for Biologics, worked on vaccines, and a lot of first of all, the vaccines that were using poxviruses as vectors, and then later, as it became more important, the actual vaccines that were being redeveloped for smallpox. And, eventually they also have Jynneos for monkeypox as well. So that was the area of the FDA I was in. And after 9/11 and after a few more years, when BARDA was created, I was recruited by someone I knew at BARDA who said that if I moved to BARDA, I could be more proactive rather than reactive and start helping people develop products rather than waiting for submissions to come in. And I found that very challenging, and so I moved to BARDA about 2 years ago.
So relevant to your background here, of course, relevant to today's discussion. So you are 100% at least pox virology, and you spent a significant amount of time in the FDA in CBER. And CBER, refresh my memory, it's a sort of you wear two hats, a reviewer and a scientist, correct?
That's correct. We have a lab and do investigator-initiated research, but at the same time, we're responsible for submissions from companies and evaluating vaccines, in this case, whether or not they are appropriate, what tests should be designed in order to make sure that they're both safe and efficacious, and in terms of moving these vaccines into the modern world in terms of manufacturing and evaluation.
So you're intimately familiar with the inner workings of the FDA and the vaccine approval process. You were even part of it, right?
Yes, actually, I was the chair for the licensure of ACAM 2000, which means that I'm responsible in signing for that. And I was also part of the team that was evaluating other vaccines that were under development at the same time.
Okay.
Now, tell us a little bit about BARDA. You said it was set up in response to 9/11, and so what was the idea?
BARDA was created in about, I think, 2006 by congressional legislation that recognized the fact that products, for example, were being developed at the NIH or by sponsors, but they were having a hard time getting them across the regulatory path to licensure, and that there were a lot of threats such as anthrax, botulinum intoxication, smallpox, where help was needed to get these products through the regulatory process so that they could be made available to the American public. And so BARDA was set up, and it was, the term that was used was called the Valley of Death, which means the time between phase 1 and licensure, which is where most products fail. And so BARDA was created, and it has a collection of specialists, some who are manufacturing, that come from, for example, Merck or Pfizer and so forth. They have ex-FDA for regulatory advice and experience. And they also have people who manage the contracts, because the way BARDA works is they award contracts to sponsors who may have a product which is usable, and then we support the development of that product both through money and through our expertise.
So am I correct then that the main cause of death in the Valley of Death is not being able to get the expertise and the money together, in particular the money, to conduct a phase 2 trial?
And that's
and beyond.
Right, and that's a lot of the rationale for establishing BARDA. And as well, there's, as you know, from a product, it's not only just the science behind it, but there's manufacturing and there's meeting regulatory requirements, and how well do you develop assays, validated versus qualified. These things all are part of the evaluation process, because the FDA holds products to a very high standard in order for them to be approved and usable by the American public. So, right, Rich, is both money and expertise. And the way that BARDA was put together, it was a collection of individuals who could deal with those problems. So
this is really important because, otherwise you're really got a big problem getting stuff moving along.
Yeah, and BARDA has been responsible for the licensure of over 60 products now, and some of them are diagnostic, some of them are small molecules and antibody-based products, and some of them are vaccines. But wherever a threat is identified where the marketplace doesn't serve well, BARDA doesn't develop heart medication or things where the marketplace can take care of what the problem is. But there's no real urge to make a smallpox vaccine or a monkeypox antiviral. And so BARDA would support sponsors that could do that.
Michael, does BARDA at all interact with DARPA?
Yes, we have strong interactions with DOD and NIH and FDA and CDC. And a lot of times we have shared meetings with DARPA in order to discuss different products. And sometimes they can be very good in the sense that we have shared goals, and sometimes the goals for the DOD are different than the goals for a civilian response. And so we have, yes.
So while you were at BARDA, you were involved in the development of the smallpox vaccines and antivirals. Can you just give us a brief history of that?
Sure. Sort of overlap. Part of the time in the FDA and part of the time at BARDA. When I was at the FDA, the first, if we go back to the seminal events, probably the first event would be the discovery that the Soviet Union was making smallpox and using this as a potential bioweapon. It was back in the early 1990s. And at that time, there was the impetus was to start making a new smallpox vaccine. Because at that time, the smallpox vaccine was called Dryvax. It's probably the one that you may have received when you were young. And it was basically what was called calf lymph. And what would happen is you'd dip a needle into a virus, and then you'd scrape it across the stomach of a cow, and you'd make a set of parallel lines, and you'd wait for the infection to fester, and then you'd scrape off that material, and that was your vaccine. And so there was only a limited number of doses, and the last manufacturing was back in 1980. So in the early 1990s, there was a push to say, can we develop a new vaccine that's based on modern manufacturing methods and could be tested and demonstrated to be effective, but at the same time not be a vaccine that's basically scraping material off the stomach of a cow. So that was ACAM 2000.
It's a terrible waste of an education to come to that point in your life.
Well, it actually turns out a cow, you can get about 400,000 doses. So,
well, that's called a cash cow, by the way.
Well, and that, that vaccine eradicated smallpox. So it's
that's right.
I think it's small accomplishment.
I think it's Jeff Smith who's always quick to point out to me that the only disease was eradicated by a vaccine that was never approved by the FDA until after the But so that was the impetus for beginning of ACAM 2000, which is a tissue culture clonal isolate of that Dryvax vaccine. And as after 9/11, there was a second sort of burst of impetus, I would call it that, is that we went from a small stockpile to a large stockpile. And so that's what we have now in terms of the ACAM 2000. And that's basically a vaccine which is the same as your father's vaccine, so to speak. And it's a very effective vaccine. And as Rich pointed out, it was very effective as a ring vaccination approach to eradicate smallpox. The drawback to it is it's a live replicating vaccine. And because of that, it's associated with adverse events, especially in an immunocompromised population, and can result in very serious adverse events, including death. And so the risk benefit for its use as a prophylactic or in a low risk environment is not low. But if there ever was a real outbreak, it's reassuring to know that we have a large amount of a vaccine which we are extremely confident would be very effective.
So the risk here is an important part of that quotient.
Yes.
And a smallpox outbreak has a different risk assessment probably than the current monkeypox outbreak.
Right,
correct?
and that's exactly right. And so one of the early attempts to say develop another or a next generation smallpox vaccine was where Geneos comes from, and that was an attempt to develop something that was safer and more universally applicable than ACAM 2000. And not necessarily to replace ACAM 2000, but to be an adjunct during a response so that you could now get vaccine into more people. If people that you weren't sure of or you were worried about because they were associated with adverse events would get Geneos, whereas most of the population would still get ACAM 2000. And Geneos is MVA based for those who know the field, and MVA stands for Modified Vaccinia Ankara. And to back up a little, during the eradication campaign, there were many different strains of vaccine that were used. Pretty much, depending on where you were, you used a local strain. In the U.S., it was mainly New York City Board of Health. In Europe, it was Lister. But one of the ones that was also used in Europe was Ankara. But Ankara was associated, as were the others, with a sufficient number of adverse events that as the number of cases dropped, it became clear that the risk of vaccination now was just as bad, if not worse, than the risk of disease in most of the world. So there was an attempt scientifically to develop attenuated vaccines, and they were done by passaging the virus through tissue culture. In the case of the MVA, it was through chorioitalic membrane and egg cells, CEFs cells. And what happened was they would pass through CEFs, they would harvest that, pass it again. And after over 500 passages, they had a virus now, which was MVA, which no longer was as potent as the Ankara starting material, grew extremely well in chicken embryo fibroblasts, but did not grow well in human cells or other cell lines. So now you have a virus which you could prepare in chicken embryo fibroblasts, which when you give it to people will be self-limiting and safer than the other vaccine. And that's the sort of rationale for Jynneos. What Jynneos is that vaccine.
And it is administered differently because of its properties, correct?
Right. I mean, the vaccine, the ACAM 2000 is a scarified vaccine where what you do is you take basically a two-pronged needle and you break open the skin and deposit a small dose there, which then replicates and forms a lesion, sort of like a pustule, which we're seeing now, for example, with the monkeypox. Jynneos is actually a subcutaneous or intramuscular injection, like most vaccines are given. And it's because of when they went through its evaluation to the FDA, it was clear that two doses gave you a prime boost regimen, which gave you a much more robust immune response than a single dose. And so that was the accepted regulatory path for development of Jynneos, two doses, 28 days apart.
So you mentioned these are both part of the strategic national stockpile. Is that what is that? Is that just vaccines or other things as well?
Yeah, no, the Strategic National Stockpile is basically a storehouse. It's in a couple different locations in the U.S. It has vaccines, it has antivirals, it has PPE, it has antibiotics, it has the number of different items that would be needed in a response. For example, if there was an anthrax attack, you'd need a completely different set of countermeasures than you would for a smallpox. So in those, those storehouses, there's also provision to store at -20, and there's things stored at room temperature and so forth.
So roughly how many doses of ACAM 2000 and Jynneos do we have there? Is that known?
I don't know if I'm supposed to say it. We have a lot of ACAM. Okay. I'll say that. With Jynneos, it was a slightly more complicated story in the fact that it has a expiry period of about 3 years in its liquid frozen form. And so we realized that we couldn't replace the stockpile every 3 years. It would be just too expensive. And we've pushed the development of a lyophilized form, which is a freeze-dried form, which preliminary data indicates it has a very long half-life. It's going to have a much longer expiry period and will be the appropriate way to go. But we don't have that formulation licensed yet. So what we've done in BARDA is we've stored the intermediate, which could be converted to the lyophilized form when it's licensed. But we're now using that to fill doses that can be now mobilized during the monkeypox crisis, because the liquid frozen form is licensed. That was shown to be effective.
So check me on this. My understanding, without any hard numbers, is that there's a lot of ACAM 2000 stored away and significantly less Jynneos. But the go-to vaccine in this particular circumstance, given the risk profile, is Jynneos rather than ACAM2000 because of the potential side effects of the two. Is that a fair statement?
I think that's absolutely correct. I think you always have to measure the risk benefit, and that one of the reasons for Jynneos as well as ACAM is to give us flexibility in response. And in this case, because it's a high transmission, low mortality virus, then what you can and should do is different than a high mortality, high transmission virus. And so, yes, Rich, I think you're absolutely correct. We have to measure the consequences of using each vaccine as well as the benefit.
The TPOXX now, however, can be and is being deployed for use in the monkeypox outbreak, correct?
Yes, but again, it does not have a label indication for monkeypox. And so for its use against monkeypox is not licensed. And so the CDER is looking to have some clinical trials in order to get real clinical evidence of its efficacy.
So does the lack of licensure then create a barrier to its use in this circumstance? A practical barrier?
It creates a practical legal barrier in the sense of what's protected under law and what would be, in terms of the PrEP Act, pays people for adverse events associated with the use of this products from the Strategic National Stockpile. But the recent declaration of an emergency drops most of those barriers.
Okay, good.
There's a certain small level of uncertainty that's still involved.
Absolutely.
Because you don't have direct demonstration of efficacy. So I appreciate how difficult it is for the FDA to make these decisions. And, from a BARDA perspective, of course, we're pushing to get those decisions made, but it's not an easy decision to make.
So Koch's postulates.
Yeah, exactly.
We're stuck with Koch's postulates because of Koch, but there's a ton of organisms out there that if he had worked on them, he would have never developed them because they're very specific for each host. And obviously some of these viruses are also.
Right.
The thing is, Michael, this is clearly now outside of a certain population where it's transmitted by close contact. We have many people who have no sexual activity getting infected now, so it's not clear what they have to change, right?
Well, close contact